to review things.
Of course, yeah.
Y'all going?
Okay, so we're going to talk about the last market structure. We finished perfect competitive market and monopoly and the monopolist competitive market. And the very last one we're going to talk about is the oligopolist market. And I think this one is the most interesting. Okay. Oligopolistic. And we already talked a little bit about this market structure in the past. Okay. And anybody remember what are the characteristics in this one? How many firms do we have in this market structure?
Few.
We have very few players. We have very, very few players. Examples are, can you give me some examples of airline market,
Cell phone.
cell phone market? Others? Soft drink industry market, that's another one, okay? And-
Cereal.
Huh?
Cereal. Everything's
Cereal.
either owned by Keebler or Kellogg.
Okay, cereal, okay, and cable,
Cable. Yeah.
cable company, cable market, okay. So that's one of the first characteristic, we have very few providers. Okay. And the second one is about the product, the goods they provided. Are they identical or heterogeneous? Are they differentiated? Same. It depends on the market, right? Okay. And if we're talking about the airline industry, okay, airline market, and even though the experience flying with one airline, it could be different from the experience flying a different airline. But usually, you know, I mean, when I book a plane ticket, I only check the price. You know, usually I'm different among the airlines. So that kind of service, you know, and providing the airline industry can be almost identical. Okay. However, you know, in other markets like auto industry, you know, and we only have the big three American automakers. Okay, so that is also oligopolistic market. But for cars, they're really differentiated. You have different models, different colors, and different kind of style design. Okay, so the products in this market could be homogeneous or heterogeneous. Okay. The third one, how about entering and exiting? Do you think there is a barrier to enter this kind of market, or there is a free entry and exit?
I think there's a barrier.
There should be barrier.
Because if there
Otherwise,
wasn't, then there'd be a
otherwise,
bunch of people in it.
yeah. Otherwise, you know, you're gonna have many providers instead of few. So there are barrier to enter or exit. Okay. Market power. Okay. Do firms here have market power?
Yes,
Okay.
they're very active in operating their own market.
That's right. Where do the market power come from? And I mentioned the two main sources where the market power comes from. One is market share, the other one is differentiation. So in this market, they have both. Because they have big market share, there's only few providers, and each provider has huge market share. And the other one is sometimes, you know, the goods are different. So differentiation and also the big market, they all both can be the source for the market power. Both market share and differentiation. Okay. Very last one, which is the most important one in this market. Huh? Somebody remember interdependence. What is interdependence? So this means each firm's action has impact on other firm's profit and action. If we see one firm's act, other firms will react to that particular action.
You said that firms in this market get their market power from market share?
Both.
From both. Okay.
Both market share and also differentiation. Okay? So interdependence, that means every time before a firm make a move, they're gonna think about, okay, how my rival firms gonna respond to my move before they make the move. So that's kind of interdependence we're talking about. So because of this characteristic interdependence, it makes the analysis harder. Because, before when we derived the optimal price, optimal output, we did not have to worry about the other firm's action. We only have to worry about, the firm's own characteristic, cost function, and the demand. That's the only thing we need to concern about when we derive the optimal price and optimal output for all previous market structures. But in this one, we cannot do that anymore. And we have to include everybody and in the picture in order to derive the optimal price and optimal output. So how do we do this? So how do we solve this problem with this characteristic of interdependence? So what we're going to do is we're going to depend on a very famous, actually it's a mathematical methodology called game theory. Okay, it was the founding father. Anybody who knows the founding father of this theory? Who invented this theory? In theory, anybody heard of it? Have you guys watched the movie Beautiful Mind? Well, right? Beautiful Mind?
I've heard of it.
You heard of it? Have you watched it?
I have.
You have? Somebody have watched it? It's a really beautiful film, okay? What is film about? Do you remember?
It's about this guy who's suffering from like schizophrenia or something like that, and
Huh?
then his wife has to help him deal with it as he deteriorates.
Uh-huh. Do you remember his name?
No.
John Nash.
There you go.
John Nash, yeah. And then I think he was a mathematician in Princeton. Yeah. And he won the Nobel Prize. And the Nobel Prize is on this game theory. Okay. And so later on, actually, because this theory is very elegant, in economics sometimes we say, okay, this theory is very sexy. Okay, why? Because it's elegant and it's simple. It can apply to so many phenomena of the observation. I'm going to show you in a minute. And so later on, even though this is just mathematical methodology, it has been adopted in biology, okay, and economics, political science, and the sociology has been applied in many other different fields. So he won the Nobel Prize and for this theory. And a couple of years ago, I went to a game theory conference because game theory is my specialized area. That's my dissertation is on game theory. So a couple of years ago, I went to a game theory conference, and he was there. So I think he died last year, actually from a car accident. Yeah. And but I was able to get his signature. And also had a picture with him. Yeah, so it's nice. He was not known for being nice. He was not a very nice guy. However, his mind is brilliant. That's why this movie is called Beautiful Mind. Yeah. All right. So now I'm going to tell you what is game theory about. Game theory analyzes interaction among different parties or players. As long as the following three conditions are met, and we can use game theory to analyze. Okay. What are the conditions? The first one. There must be more than one party involved. There must be more than one party involved.
As far as economics goes, would a party mean a firm or a company?
It can be anything. Could be firm, could be individual, could be country. Yeah. So the setting or the environment, the situation where we can analyze this condition. There are more than one party involved. Okay. The second one. Each party pursues its own interest. Each party pursues its own interest, but no party can really dictate the outcome. Okay, the second condition. The second one, the third one, each party's action has impact on the other party's action and the payoff. Has impact on other parties' action and payoffs. Each party's action has impact on other parties' actions and payoff. So as long as these three conditions are met, then we can use game theory to analyze. So you can see a lot of environments or situation or setting satisfy those. Okay, give you example, presidential campaign. How many presidential candidates we have? More than one, right?
Like 8 or 9.
Yeah. Each candidate pursues his or her interest, which is to become elected. Okay. Okay. And each candidate's action, speech or action, is going to have the impact on how likely the other candidates will be elected. But no candidate can really dictate the final outcome, right? So we can use game theory to analyze the presidential campaigns. And in biology, actually, they use game theory to analyze how the cells in our body, in our bloodstream, interact with each other. So economists, and particularly interested in this game theory because we can use game theory to analyze the firm's behavior, like in the oligopolistic market. Okay, because in the oligopolistic market, the firms interact with each other. Each firm's action is going to have influence on other firms' behavior and payoff and profit. Okay, so that's why eventually game theory was adopted, by economists and become a very important field in microeconomics. Okay, that's what I specialized in, and for a number of years. Pure theoretical, okay, pure theoretical. All right, so now I'm going to show you an example and see how we're going to use game theory to analyze the behaviors in a oligopolistic market. Okay, very simple example, but it will show you the beauty of this game theory. I'm going to give you an example, which we call the duopoly.
Instead of one party controlling everything, it's two.
There's only two firms in that oligopolistic market, two firms. Okay. Duopoly. So this time we assume that in this market we have two airlines, okay? Continental Airlines and United Airlines. And suppose these two airlines compete for business on a particular route. And this route is from Washington, D.C. to Beijing, China. Okay? So they compete on a particular route from Washington to Beijing. So we have two players, called players. So I'm going to use game theory terminology right now, okay? And so we have two players, okay? And each player has two strategies to choose from, okay? So the strategies. What strategy do they have? Okay. How do they compete on this on this route? They can either offer a regular price, which costs $1,500 for the round ticket, economy class round ticket, and or they can offer a discounted price, which is $1,000. Okay. So strategy is just two. They can either offer a regular price, or they can offer a discounted price. So each one of them has these two strategies to choose from when they compete on this particular route. And here we assume that they make simultaneous move, which means they determine what price to offer at the same time. That means Continental Airlines cannot know United Airlines price before they make the decision. Neither party, neither player know before how the other party is going to behave. Okay?
So there's no interdependence?
There is. I'll show you. Okay? It is simultaneous move. Later I'm going to show you a game that is sequential move, which means one party make a move, then the other party make another move. Like a chess game, that's a sequential move. But sometimes, the game setting is simultaneous move. You make the move, make the action, act the same time. Okay? So when that happens, then we analyze it differently. Okay, so I'm going to show you the payoffs, okay, come out from different possibilities. Okay, so this represents United Airlines. This represents Continental Airlines. Each of them has two strategies to choose from: regular price, discounted price. Regular price, discounted price. Okay, so how many different possible outcomes we can have? We have four, okay? Okay. If they both offer regular price, which is $1,500 round trip, they're going to split the market. Each will have the half of the market, okay? And each one of them is going to make $1.2 million, okay? The left number here represents the profit made by the Continental. The right number here represents profit made by the United Airlines. Okay, so this is what we call payoffs. So in order to set up a game setting, you have to have player, you have to have strategy, then you have to have payoffs. Okay. 3 components in order to set up a game. If both of them offer discounted price, which is offer $1,000 for round trip, again, because they offer the same price, they're going to split the market. Each one, they're going to have half the market. But they're going to make less money this time. They're going to make $0.6 million. They offer less price, they make less money. but still they split the market. Now let's look at the other two situations, which represent the one firm offer a regular price, the other firm offer a discounted price. What do you think is going to happen if United Airlines offer $1,500 and the Continental Airlines offer $1,000 for round trip? What's going to happen?
The Continental
United Airlines gonna get most of the market.
Nobody, assuming we have enough seats, and nobody's going to buy from United Airlines. Everybody's going to buy from Continental Airlines. So in this case, Continental Airlines is going to get whole market, okay? And the number is as follows. They're going to make $1.6 million, and the other guy is going to make $0. Vice versa, if United Airlines offer discounted price, Continental Airlines offer regular price, then Continental Airlines is going to make $0, United Airlines is going to make $1.6 million. So this is what we call a game theory setup. And this format here we call norm form representation. Because in this representation here, you have players, you have different strategies for each player, and then you know the payoffs here there. Okay? Once we set up this game setting and we're able to solve this problem. So the question for you is, there are 4 possible outcomes here. What's your prediction? Which one we're going to end up with? They make the move simultaneously, remember, simultaneously. Jun.
Both of them are operating with the knowledge that the other has the option to make the discount. So I think in order to make the most profit without the risk of losing all of their profit, both of them would go with the discounted price.
Go what?
With the discounted price, both of them would go with it.
Go the discounted price. So they both going to make 0.6?
Yeah, just because if one of them takes the risk of going at the regular price, then they might end up losing all of the market and making $0.
Okay, okay, very good.
It's the safe bet.
Okay, very good. So do you agree with him? Any different opinions?
I think they're gonna go with the regular price because they have the share of the market, so they can just charge whatever the heck they want to, and keep.
You know, and we can see that's definitely is better outcome than the discounted. But here, we're interested in what we call this. Nash equilibrium. And this is named after John Nash. So that character in that movie, you know, yeah. So so I'm not going to tell who is right, who is wrong. I'm going to analyze this game using the game theory approach. Okay? All right, so what is game theory approach? It's very simple. You got to remember this. Okay, if one thing you have to remember today, that's game theory methodology says this. If you want to know how each player behave, you have to fix the other player's strategy. That's the essence of the game theory methodology. If we want to figure out each player's strategy, we have to fix the other player. How do we do it? Let's start with Continental Airlines. Suppose we want to know how this guy should behave. What is the optimal thing for this guy to do? Then you have to fix the other guy's strategy. So let's assume, suppose United Airlines choose to offer regular price. If United Airlines choose to offer regular price, then the Continental Airlines either get 1.2 or 1.6 million dollars. Which one is better?
1.6.
Okay. So if Continental Airlines knows this guy is going to choose to offer the regular price, then the best strategy for Continental Airlines to do is to offer discounted price, which give him 1.6. So you mark this number underneath. Okay. So this is when we fix UA on the regular price. So now let's fix UA again. Suppose United Airlines choose to offer discounted price. Then we look at these two boxes here. Now can you tell me what's the best thing for Continental Airlines to do? Offer discount, because 0.6 is better than 0. This is called game theory methodology. When you figure out one guy's action, you have to fix the other guy's strategy one after one. Then determine what's the best thing for him to do for each individual fixation.
Could you do that last fix with Continental Airlines? I don't think I followed.
Okay. Last fix is United Airlines fixed here.
Right.
United Airlines choose to offer discount. When United Airlines choose to offer discounted price, Continental Airlines either get 0 or 0.6. Of course, 0.6 is better. So Continental Airlines should offer discounted price.
Okay.
Is everyone with me on this?
And you called that the game theory
Methodology. This is the game theory methodology. Fix the other guy when you figure out one guy's strength. All right. So just from this analysis, what can you conclude about this guy's action or optimal strategy?
Interdependence.
Hmm?
Is it interdependence? Is it a type of interdependence?
You should always discount it.
You should always discount it.
You don't-
No matter how United Airlines choose to do. You can choose to here or can choose to here. But the optimal strategy for Continental Airlines remains the same, right? It's discounted here and it's also discounted here. So no matter how United Airlines choose to do, it's always the best for Continental Airlines to choose offer discounted price. Everybody's with me on this? Just
So United Airlines would use this to figure out what they should do, knowing that Continental's always going to discount their price.
yes? Yes. So we have a name for this situation. This name called dominant strategy. So the second term here is dominant strategy. Dominant, if a player has a dominant strategy, what does it mean? That means its optimal action does not depend on how the other players plays. Basically, no matter how the other player plays, you always have the same best strategy.
If they use the discounted price all the time, wouldn't that just become the regular though?
If this guy offer discount, this guy's offer discounted, they will end up here.
I'm saying, but as a consumer, you're always gonna think that price is there.
Yeah,
but-
psychologically, the consumers think, oh, then that's it, right? There's no, yeah. But, here, we assume that, and this is a one-shot game. So you're talking about if it's happen again, then it will give the impression to the consumer there's only that one product offered, yes. But, yeah, so here, it's one-shot game, one period, there's no future. Okay, so Continental Airlines here does have a dominant strategy. In a lot of games, players do not have dominant strategy, but in this case, Continental Airlines has one. Now we have figured out Continental Airlines' dominant strategy, which is offer discounted price. Can you analyze UA's best strategy using the same methodology I just introduced you? How do I do it? Somebody want to show how to do it? You want to try it?
So, because like if I work for United Airlines, I can tell them that since we know that Continental is always going to discount their price, if we offer a regular price, we'll make no money and they'll take the entire market. So we should also offer the discounted price so that we can at least, because we know that they're going to offer the discounted price, so we should compete with that
That's
as
true.
long as we can.
The analysis is accurate. It's accurate. But I'm going to do the traditional approach, which means what if I did not start with this? I start with that.
Okay.
Okay?
It'll be the same way.
Do the same way, right? Okay, how do I do it? So we start with United Airlines. So how do I do it? We have to
The fix at regular.
fix Continental, right? Okay, so when we fix Continental, let's say Continental choose to offer regular price, then we'll look at this row here. We are comparing this number with that, right? Which one is better?
1.6.
1.6. So which means if Continental Airlines choose to offer regular price, then the best strategy for United Airlines is to offer. Now we have to fix this again. Assuming Continental Airlines choose to offer discounted price, then we're looking at the last row here. The number we have to compare is 0 and 0.6, right? So if United Airlines offer discounted price, they will end up with 0.6.
So then both players have a dominant strategy.
But that's right, both players in this case have dominant strategy, which is to offer discounted price. So that's the definition of the dominant strategy. I'm going to show you later on in the case where only one player has dominant strategy. And also I'm going to show you example where both players have no dominant strategy. But in this case, it's kind of unique, special. Both players have dominant strategies. All right. Then which one is our Nash equilibrium?
That one.
That's the only one that both numbers are marked underneath. So this is our Nash equilibrium. Is this the ideal outcome for both players?
No.
No, it's not. It's not. But since we only have one shot game, what does that mean? There's no future to worry about. There's no reputation to concern them. Okay? When there's no future, there's no reputation concern for them, they only have to worry about the current profit in this particular period. That's how they behave. But if there is a future, there's a next year, the year after next, then this may become a Nash equilibrium. So that would be more complicated analysis because that we call it repeated game instead of one-shot game. In a one-shot game, this is what we end up with because they don't have to worry about their reputation or future concern. Okay? Any question on this? Is it straightforward? It is straightforward, but you need to practice to be more comfortable of deriving the equilibrium. I'm going to give you a couple of examples. Okay, just for you to practice using the game theory approach. I just said we have a player A here, player B here. Each one not cheat, not cheat, cheat, not cheat, cheat. So each one of them has two strategies to choose from. Okay. Alright, so I'm just going to give you minus 2, 8, 8 minus 2, 2 and 2. Use this as a practice. Remember, the left number represents A's payoff, and the right number represents B's payoff. So I want you to use the same kind of method we use, those kind of marking as well, to figure out, okay, first thing, does any player here have dominant strategy, and what is Nash equilibrium? Later on, the game we're gonna play actually is from this chapter. Okay. Where you're going to earn some extra credit. Figure out A first, you have to fix B, column by column. Does A or B have dominant strategy here?
No.
Yes or no?
Yeah.
Yes, no. Others? Yes or no? Yes or no? Somebody solved it? Yes or no? We do have dominant strategy. Others? Okay. Did everybody figure that out? Figure out A first or fix B.
Fix A first.
B is here, choosing not cheat. What A should do? Not cheat, get 5, cheat, get 8. Which one is better? Cheat. Your mark here. Fix B again. Then A can get -2 or 2. Which one is better?
Two.
Does A have dominant strategy? Yes.
Oh, and not cheat. No, and cheat.
Cheat. Always cheat, right? Always cheat, right? Okay. And do the figure out B the same way. Do those markings
thing.
here.
And they should cheat too.
They should cheat too. How do we do the markings?
No, we should not cheat.
No.
No, not cheat.
Yeah, not cheat.
Let's do it again together, okay? So let's figure out B, then fix A. Looking at here, right?
They should cheat.
8 or 5 is better for B.
Oh.
8. It's the same thing.
Let's fix A again. Looking at this row here, -2 or 2 is better.
2.
So B always cheat as well. So the same situation as we had here.
So the dominant strategy would be to always cheat.
Cheat and the Nash equilibrium is cheat. I think some of you may be messed up with this because you still cannot left number represent A, right number represent B.
Like, how come these two like companies or whatever, like they just both like, cause for the first one they would either be making 0.6 or 1.2, and like obviously 1.2 is better for both of them. So why don't they just both agree to not do the discounted price, or like on this one,
Okay.
why don't they both agree?
Good
not
question.
cheat?
Very good question. If they had a chance to collude, they would do that. But here we assume that that's illegal. It's illegal, and they have to enter into what we call competitive environment. If they have the chance to collude, and they will definitely do those. That's actually the one of the biggest antitrust cases, price fixing. They fix on price implicitly, because if they fix on the particular price explicitly, that will be against the law. Yeah. Yeah, if they do give the chance, yeah, they will do that. But in a repeated game, if they are given multiple period of time, even they are still in a competitive environment, but that kind of reputation concern may kind of make them compelled to cooperate instead of, cheating. Oh,
Can you be just one more time, please, so I can make sure? I
Sure.
understand?
okay. So first we start with A. Okay, we're trying to solve A's problem. Okay, when trying to solve A's problem, we have to fix B's strategy. Let's fix B's strategy right here. Saying B choose not to. If B choose to here, A can get 5 or 8. Because left number represent A's payoff. Okay, which one's better? We know 8 is better. So which means A is going to choose to cheat if B does not cheat.
Okay.
Okay? So then we have to fix B again. Let's assume B choose to cheat. If B choose to cheat, A can get -2 or 2. This is better. So that means A is going to cheat again if B choose to cheat. So no matter B does not cheat or cheat, A is always going to cheat. So you mark those numbers underneath. Why we want to do the marking? Because then after you all finish this analysis, the numbers have both marked at the Nash equilibrium. Okay. So let's do another practice. This case, it may be different. You know what? I'm looking into this.
That's good.
We have 2 players, but now each player has 3 strategies to choose from.
My back cut.
we'll have one more strategies to work with, but the same methodology. This time, if you do not do the marking, you will be lost here.
Is on column A all the way at 100, or like where B is, where they're looking, is that 740?
740.
Okay.
Copy these tables there, and then work on player A strategy. Just start with player A first.
So very bottom right one, 750 and 750.
750, 750, yep. The very last one's 3. Third row, third column, 750, 750.
That's 795 with 175. Like for B, 75 and 100. For A, is that 795?
745.
No, down. Over to the left. Right there. And it's 745 or 700?
745. 745.
For which one?
We fix A. I'm sorry, we figure out A. So we fix B. How many times we have to fix B in this example?
That's 1,000.
3 times, right? Okay. When we fix the B here, which number we should mark?
The 1,125.
The last one.
125, right? When we fix the B on 75, which number we should mark?
890.
890. You mark that.
So we fix B on.
We fixed B the last time. Which number we should mark?
750.
So, okay, so if they choose, if A
Okay,
chooses
so we finished A. Does A have dominant strategy?
100.
Does the A have dominant?
Yes.
Yes? You sure?
I'm pretty, I think.
Absolutely sure.
Absolutely. Okay.
Okay, so we finish A. Let's do B. Okay? So which means we're gonna fix A.
Okay.
Look at this first row here. Which number we should mark?
1125.
20.
1125. We fix the second row here. Which number we should mark?
890.
890. Third row, which number?
750.
750.
Okay. Does B have a dominant strategy?
Yeah.
Yeah.
Do we have Nash equilibrium?
Yes.
Okay, good.
Will
Very
it
good.
always be the bottom corner?
No. So now you feel comfortable. Next time when I bring an example, it's totally different.
Okay.
This basically these 3 examples are all similar, right? They all have dominant strategy, same Nash equilibrium there. But next class we're going to practice some odd kind of examples.
Will there be some times where there isn't a Nash equal?
Yes, I'm going to give you that example next class too. Okay? Please sign your sheet, and also I'm going to sign the homework on Monopoly, competitive market, and Monopoly both. Okay?